Section 5.1 talks about normal distributions and something that we're going to call the standard normal distribution. So, properties of a normal distribution. It says in Chapter 4, we discuss discrete and continuous random variables. In 4.2 and 4.3, we worked with discrete probability distributions like the binomial, geometric, and Poisson. And in Chapter 5, we're going to begin to work with continuous random variables. Recall that a continuous random variable can take on an infinite number of possible values, and continuous probability distributions are created to reflect those possibilities. The most important continuous probability distribution in statistics is something called the normal distribution. So it says a normal distribution is a continuous probability distribution for a random variable x. The graph of the normal distribution is called a normal curve. A normal distribution, has these properties. The mean, median, and mode are equal. The normal curve is bell-shaped and symmetric about the mean. The total area under the curve is equal to 1. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. We're talking about this right here. It gets closer and closer and closer to the x-axis, guys, but it never actually touches. Between mu minus sigma and mu plus sigma in the center of the curve, the graph curves downward. So it's going down here. And then the graph curves upward to the left. So now the graph is kind of shaping upward. I know I'm going down, but the curve is up. And the curve here is up as well. Okay, and these right here are what we call inflection points, where the curve of the graph changes, okay? So let me bring this down a little bit more, but that's where our inflection points are. Okay, so just a couple of pieces of information. Here is my mean, right? The difference between in here and here is my sigma, which is my standard deviation, okay? Pardon me. It says discrete probability distributions are graphed with histograms. However, continuous probability distributions are graphed with probability density functions, where the total area under the curve is 1. Okay. So means and standard deviations. A normal distribution can have any mean and any positive standard deviation. These two parameters are actually what shape the distribution. The mean gives the location of the line of symmetry, and the standard deviation describes the spread of data. Okay, so let's talk about these two. The mean is going to give the location of the line of symmetry, and the standard deviation is going to give us the spread of the data. Okay, so let me keep going here, and we're going to see if we can answer the first question. And the first question says, match the normal curve with its parameters. All right. So first thing I want you to notice, look at the mean in every case. So in two of them, the mean is 3.5, and in one of them, the mean is 1.5. So here is the mean of 1.5. Let's do this one first. Which one of these graphs here, A, B, C, would be matched up with, say, this part here? Well, it looks like this one would, right? Because here is 1.5. Okay, now look at my standard deviation. It's 0.7, right? So that's just telling me that the difference between there and that distance between here and here is going to be 0.7, right? Notice 0.7 is a small number, isn't it? So because that number is small, that means the spread is small. So look at all the data is contained in this very narrow graph, okay? So now what I want to do is I want to look at the other two, right? So let's look at this one here and this one here. So they both have means, of 3.5. But the standard deviation here is 1.5 and the standard deviation here is 0.7. So the one that has the zero point 0.7 standard deviation, that graph should be more narrow. So if you look here, here's my 3.5, and again, the distance between here and here, 0 0.7. Why? Because it's much smaller, right? Now look at this one here, 1.5. So here's my 3.5, here is my mean. But look, if I add 1.5 to it, 3.5 plus 1.5 would give me 5, right? Or 3.5 minus 1.5 would give me 2. So you can see that the bigger the standard deviation, so bigger standard deviation, then the graph is going to be more spread out, right? Okay, and then that means that on the other hand, if this is going to be smaller, oops, that's not how you spell smaller, then the graph is going to be more narrow, right? All right. So now let's take a look at number 2. Number 2 says, answer each question below pertaining to the normal distributions. Okay, so part A says, which normal curve has the greater mean, right? The bigger mu, right? The bigger mu is going to be the line of symmetry, okay? So wouldn't graph B, right, be this one here? So we'll say graph B for the first part, okay? Now, let's take a look at part B. Which graph has the greatest standard deviation? So which graph is more spread out, right? Because the bigger the standard deviation, we said the graph was going to be more spread out. I would say C. Look at the graph of C, right? It's more spread out compared to A and B. Okay. Which two curves have the same mean? Well, remember the mean is that line of symmetry. Oops, that line of symmetry. So I would say A and C, right? And then part D says, what is the mean for curve B? So the mean for curve B, if I go straight down, wouldn't that be 60? Okay. All right. So question number 3 now says, what is the mean weight and the standard deviation for all newborns born in the U.S. in a recent year? Okay, so the first thing we're going to do, we're going to find the mean. So the mean, guys, is going to be the line that cuts the graph right in half. So it looks like my mu is 3,300, right? Okay, so now notice how the graph is curving downward here, right? And then right about this point, it starts to curve upward, right? So we're trying to guess roughly, what would those numbers there be, okay? So I might say that, say, this number right here in the middle, this number right here, that number might be, say, 2,500. So if I wanted to find the distance between those two numbers there, I would say, well, what's 3,300 minus 2,500, right? Grab my calculator, turn it on. 3,300 minus 2,500. That'd be about 800, and that would be my standard deviation. Okay, I could have done it over here too. I'd have to kind of guesstimate, right? And I might say, like, I don't know, 4,200 or something like that, right? 4,300, one of those two, and I would kind of go from there. Okay, so let's take a look at number 4. Number 4 says the scale test scores for the New York State grade English tests are normally distributed. I'm sorry. Estimate the mean test score and the standard deviation. Okay, so let's do the same thing. Here's going to be my mean, right? My mean is the number right in the middle. Okay, so let me see if I can draw that a little bit better. I'm doing this kind of freestyle. Right about there. That looks about right. Okay, so this is 640 and that's 660. This got to be about 650. So I don't know. I might guess 655, right? Okay. And then we're going to find our inflection points. Inflection points are right about here. We're going to go down. Okay. So I can either go find the distance from there to there, or I can find the distance from there to there. So this is 680. And if I subtract 655, right, 680 minus 655, isn't that going to give me about 25? So this would be my standard deviation, right? Okay. So another problem, very similar. What is the mean of the normal curve and estimate the standard deviation? Okay, so let's go for the mean. We're going to go straight down. That looks like to be 52. Okay. My standard deviation is going to be right here where I have those inflection points. Go down, okay, so we can say, let's take 52 minus 40, and wouldn't that be 12, right? Or if you wanted to do 64 minus 52, you'd still get 12. So in either way, how you do it, you're going to get the same answer, right? Okay. Oops. So the next part here, we have the standard normal distribution. And it says the reality is that there's an infinitely many normal distributions to represent infinitely many situations with infinitely many means and standard deviations. The normal distribution with a mean of 0 and a standard deviation of 1 is called the standard normal distribution. Okay. Boom. So we got that. Let's take a look here. And it says the total area under the curve is equal to 1. All right. And now it says note that the horizontal scale corresponds to z-scores. So what we're doing is we're going to sort of think of everything in a standard normal distribution where the mean is going to be 0 and my standard deviation is going to be 1. Okay. So it says here, recall that a z-score for a random variable x is a measure of position that indicates the number of standard deviation the value lies from the mean. And here was our formula for computing our z-score. We were going to take the value minus the average divided by the standard deviation. And it says when each value of a normally distributed random variable x is transferred into a z-score, the result will be the standard normal distribution. The cool thing is that the area that falls under the non-standard normal curve is the same area under the standard normal curve with the corresponding z-values. The empirical rule helped us determine the area under the curve for the values that were 1, 2, and 3 standard deviations from the mean. We will now examine finding the area under the curve for all values of the random variable x using the standard normal table, which lists the area under the standard normal curve to the left of any z-score from negative 3.49 to positive 3.49. Okay, so couple of properties that we have here. It says the properties say the cumulative area is close to 0 for scores z is equal to negative 3.49. The cumulative area increases as the z-scores increase. The cumulative area for z equals 0 is 0.5. And the cumulative area is close to 1 for z-scores close to z is equal to 3.49. So when we're finding the area using the standard normal table, I'm going to show you that part in a minute, guys. It's always telling us the area to the left. So it says if you're over here 1, 2, 3, if you're over here about 3.49, the area underneath that is going to be really close to 0. When you're finding the z value, the area here, remember the area in the whole thing is 1, so the area at the middle is going to be half. And then if you're finding the area here, which is everything to the left, it'll be really, really close to 1. Okay, that's what that part is telling me. Okay, so it says, we're going to do this a couple of ways. The first way says, find the cumulative area that corresponds to a z-score of negative 1.25. So I want you to think about that. Here's negative 1, negative 1.25 would probably be about right here. And what it is we're looking for is we're looking for the area to the left of the curve, okay? So the way we're going to go ahead and do that, I'm going to pull up the standard, or it's called the Z table, okay? And we're looking for when, let me come back, when Z was what, negative 1.25? So I'm going to scroll down here. I'm going to look for Z is equal to negative 1.25. Okay, oops. Okay, here is negative 1.2. And See how there's the 0.5 here? So what I'm going to do, negative 1.2, and down here, and these two right here, that would be negative 1.25. The number that I'm coming up with is 0.1056. So I would say the answer here is going to be 0.1056, right? And that's how I can do it using the table. Okay. Excuse me. There's a way I can do this on my calculator. So I want you to think about my x-axis for a minute. Okay. Here's my x-axis. Notice this is negative 3, negative 4, negative 5, right? Negative 6, so on and so forth. And this would be 4, 5, 6, so on and so forth. Now remember what we said about the graph. This graph gets really, really close, but it never touches, right? It goes up here, and over here gets really, really close, but it never touches. So if I was trying to find the area, if I'm going to keep going all the way to the left, I would say, well, all the way to the left would be negative infinity. And if I were to go all the way to the right, that'd be positive infinity. So I can do this on my calculator using something called the normal CDF, okay? The normal CDF is going to ask me for a lower limit and an upper limit, okay? So in my lower limit, usually what I put, if I'm going to go all the way to negative infinity, usually I just put like negative, a whole bunch of 9s, right? And then where are we going to stop at? We're going to start right here at negative 1.25. Okay, so I'm going to do this on my calculator. I'm going to bring this over so you can see what I'm going to do. Turn it on. I'm going to go second vars. Okay, and you look at the second one. You see how it says normal CDF? I'm going to enter that. Okay, first number I'm going to type in, guys, negative and a whole bunch of 9s, right? How many 9s do you want to put? As many as you want. I would put more than one. Okay, I'd put at least 3. And then to negative 1.25, okay, we're going to close it off. What this is going to do, this is going to tell me the area under the curve. We should be coming up with 0.1056. And if you notice, the first 4 digits, 0.1056. Okay? You got 2 ways to go about doing it. If you want to use the table, here's your table, right? Now, you're going to have a copy of this in your week 7 folder, okay? So it'll be there. But you'll have a copy of that. If you want to use the calculator, I just showed you how to do it. All right? So let's take a look at the next one. And it says, find the cumulative area that corresponds to a z-score of 2.15. Okay, oops. So look, it's a positive 2.15. So it's going to be right about here. Okay? So I want you to think about this area. I'm already looking at more than half of that curve. So I know my area is going to be more than 0.5. And it's almost the whole thing, right? So again, if I wanted to use my table, 2.15, right? I'm going to scroll down. These are all negative, right? These are all negative. Okay. So here we go, 2.1 and 0.5, right? If I put those together, 2.1 and 0.05, that gives me 2.15, right? So if I go this way, right here, 0.9842, that's the answer that I'm coming up with, 0.9842. If I were to do this on my calculator, what I would do is I'd say, look, let's do the same thing. Let's go second vars. Let's go to our normal CDF, okay? Now remember, I'm finding the area to the left of the curve, so I'm going to start at negative a whole bunch of 9s, comma, 2.15, close it off, right? I'm going to hit enter, and if you look at my first 4 digits, 0.9842, right? Okay, so one thing I want to mention about using my table, guys, my table, if you notice right here, it's always given me the area. See, it erased it. It's always given me the area to the left of the curve, right? Always the area to the left, okay? So look at the next problem here. Now this next problem says, find the area under the normal standard curve to the right of negative 1.05. So negative 1.05 would be somewhere right about here. Negative 1.05, right? And we want to find the area going this way. Well, the way we're going to do that is we're going to say, well, let's find the area to the left, And then once we find that, then we can take 1 minus whatever number we got, right? Because the area under the whole thing is always going to be equal to 1. So if I was going to use my table, right, I'm going to go to negative 1.05. So let me come back up here to my table. And negative 1.0. So here is my negative 1.0. 5, I want to say, is right here, negative 1.0, negative 1.0. Where is it? Here we go. So I'm coming up with 0.1469. Okay. So I would have to go 1 minus 0.1469, right? And I would take my calculator, 1 minus 0.1469, and I would come up with, oops, what was it? 0.8531. 0.8531. That would be my answer, right? Okay. Now, again, I'm showing you both ways, guys, so that you can determine which way do you enjoy, which way do you like better. Now, remember, when I'm using my calculator, my normal CDF, right, the first number I always type in is my lower limit. So we're going to go like this. Normal CDF. And I'm going to go like this. Lower limit. Oops. And upper limit. Okay. So I want you to notice, what am I looking for? I'm looking for the area to the right, right? So I would go normal, CDF. The first number I'm starting off at, negative 1.05. If I'm going to go all the way to the right, now I'm going to go a bunch of positive 9s, right? Oops, that's not what I was looking for. Oops, that's not what I was looking for either. Hold on, guys. Okay, so now I'm going to go second vars, normal CDF. Oops, number 2, right there. And I'm going to start at negative 1.05, comma, and then a whole bunch of 9s. Close it off, hit enter. And am I coming up with 0.8531? Yep, that's the same answer that we got earlier, right? Okay. So let's keep scrolling down. Okay, and here it says, find the area under the normal standard curve to the right of negative or positive 2.50. Okay, so 2.50, and I'm looking for the area over here, okay? So it's going to be a pretty small number, right? I know that. So remember, the way I can find that is if I use my table and I go to when z is equal to 2.50, it's actually going to give me all of that area, but then I can do 1 minus whatever number we're going to get. So let's come back over here. Let's go to 2.50. So 2.50, let's see, where's the 0 in this case? The 0 is the first one right here, right? So 2.50 is 0.9938. It's this piece right here, 0.9938. 0.9938. Okay. So I take my calculator, 1 minus 0.9938 equals 0.0062. Okay. If I was going to do this again on my calculator, notice how I do it. I'm going to go normal CDF. Oops, CDF. Okay. Remember, we're really looking for this little smidget right here, right? So what's my lower limit? 2.5. What's my upper limit? A whole bunch of 9s. Okay, so second vars, normal CDF, 2.5, comma, a whole bunch of 9s. Okay, and I'm coming up with 0.0062. Hey, it's the same thing, Jelly Bean, that we got right there. Okay. All right. Look at number 10. Number 10 says, find the area under the standard normal curve between negative 1.25 and 0.065. Okay, negative 1.25, right here, negative 1.25, and 0.065, or 0.65. 0.65. Okay. So what is it we're looking for? We're looking for the area in the middle. Okay. So if I'm going to do this on my table, first thing I got to do on my table, I got to find the area to the left of that, right? So let's go to when z equals negative 1.25. Get my chart here. Negative 1.25. I'm going to scroll up to the top. Okay, here's my 5. Negative 1.25 is right here. It was at 0.1056. Okay. So this gave me a 0.1056. That's the area right here. Now, if I go to 0.065, that's going to give me all of this. And then what I'm going to have to do, guys, is subtract those two numbers. So 0.065, 0.065, let's do that. 0.065 is right here. 0.7422. 0.7422. And then we'll just subtract those two numbers. So 0.7422 minus 0.1056. And I'm coming up with 0.6366, right? Isn't that the number we came up with? Yes. Okay. Now, if you're going to do this on your calculator, what are we going to do? We're going to go normal. CDF. Oops, CDF. What's my lower limit? Negative 1.25. What's my upper limit? 0.65. And to get my calculator here, second vars, normal CDF. Let's see, we said negative 1.25, comma, 0.65, comma, enter 0.6365, and we're pretty darn close, aren't we? Okay. All right, so guys, I'm going to do the same thing here for this one. I'm just going to use my calculator on this one here, but I already showed you all how to do it. Normal CDF, and I'm going to go negative 1.5, comma 1.5. So let's go second vars, normal CDF, negative 1.5, comma 1.5, comma, and I'm coming up with 0.8663, or 4 actually, 0.8664, right? And we found the area, right? Negative 1.5 and positive 1.5. That's what we're looking for, right? Okay, so last problem here says in the next section we're going to learn how the area under the curve for a given value of z is actually the probability that z is less than that z-score. Excuse me. And it just says, for example, since the area to the left of z equals z of negative 0.099 is 0.1611, then the probability that z is less than 0.99 is 0.1611. Transforming non-standard normal distributions to z-scores will help determine probabilities of certain events. Okay, it says, refer to problem number 4 regarding the scale test scores for the New York State Grade English test are normally distributed. What's the probability that a student chosen at a random score, what's the probability that a student chosen at random scored less than a 640 on the test? Okay. So remember what we're going to do here. We're going to do x minus the mu divided by the standard deviation, right? Okay, so we did this earlier. Let me see if I can scroll up. What do we come up with for our x? Here we go. We said that the mu was 655 with our standard deviation being 25. Okay. So we said that in this case, we said mu was 655, and my standard deviation was 25. Okay. So the x value that we're interested in here, guys, is 640. So I'm going to take 640 minus 655, and I'm going to divide it by 25. Okay. It's going to give me a negative 15 divided by 25. And let me get my calculator. Negative 15 divided by 25. And I'm coming up with a negative 0.6. Okay. So now we're looking for what's the probability that a student scored less than 640. So all I'm going to do is I'm going to go to my chart and I'm going to look for the area to the left of negative 0.6, right? So these are the positive values. So let me scroll down till I get to the negative ones. And we want exactly negative 0.6. Oops. The negative ones were at the top. Sorry about that. Here we go. Negative 0.6 is going to be, look, the 0, 0 here is on the right, right? So really what I'm looking for is that number right there, 0.2743. So the probability, oops, that a student scored less than a 640 would be, what did we say it was? 0.2743, right? 0.2743. And that would be my answer.